This PowerPoint looks at experiment design and a little bit about observational studies and what the differences are. An experiment deliberately imposes a treatment on a group of objects or subjects in the interest of observing the response. So something is actually done to the participants. This differs from an observational study, which involves collecting and analyzing data without changing existing conditions. It's really important with an observational study that we try not to interact with the subjects because we don't want to create a reaction. We just want to see what is normally happening. Because the validity of an experiment is directly affected by its construction and execution, attention to experimental design is extremely important. In experiments, a treatment is something that researchers administer to experimental units. An experimental unit are the individuals involved with the experiment, the people who you're giving a treatment to, or it might be an object or something like that that you're using as experimental units. A cornfield is divided into four, each part of which is treated with a different fertilizer. So each of those parts of the field are experimental units. A teacher practices different teaching methods on different groups in their class to see which yields the best results. So each of those different groups is an experimental unit. Treatments are administered in what are to experimental units by level, where level implies an amount or the magnitude. So if the experimental units were given 5 milligrams, 10 milligrams, 15 milligrams of a medication, those amounts, those number of milligrams, would be three different levels for the treatment, which can then be compared. A factor of an experiment is a controlled independent variable, a variable whose levels are set by the experimenter. So that would be the independent variable. Different treatments constitute different levels of a factor. Three different groups of runners are subjected to different training methods. The runners are the experimental units, the training methods are the treatments, where the three types of training methods constitute three different levels for the factor type of training. Experimental design. It is wise to take time and effort to organize the experiment properly to ensure that the right type of data and enough of it is available to answer the questions of interest as clearly and efficiently as possible. This process is called experimental design. Control is a major aspect of creating an effective experiment. Suppose a farmer wishes to evaluate a new fertilizer. She uses the new fertilizer on one field of crops, A, while using her current fertilizer on another field of crops, B. The irrigation system on field A has recently been repaired and provides adequate water to all the crops, while the system on field B will not be repaired until next season. She concludes that the new fertilizer is far superior. Well, her results are not going to be trustworthy because there's a different factor that she's not taking into account, which is the irrigation system. See, the problem with this experiment is the farmer has neglected to control for the effect of the differences in irrigation. She can do that by doing what's called blocking, and we'll look at that later. This leads to experimental bias, the favoring of certain outcomes over others. Whichever treatment she's giving to the field that has a proper irrigation is going to do better. To avoid this bias, the farmer should have tested the new fertilizer in identical conditions to the control group, which did not receive the treatment. Without controlling for outside variables, the farmer could not conclude that it was the effect of the fertilizer and not the irrigation system that produced a better yield of crops. The placebo effect you have probably already heard of. It's another type of bias that most apparent in medical experiments. It's called the placebo effect. Since many patients are confident that a treatment will positively affect them, they react to a control group which actually has no physical effect at all, such as a sugar pill. So just because you think you're being treated, you may start to actually improve. To counter that, they have one group that gets a fake treatment or a placebo, and they can measure their results, which includes feeling better because you think you're being treated, to a group that actually is being treated. A double-blind study. Placebo groups may not be sufficient for avoiding bias in experiments. If a placebo group knows they're not getting an actual treatment, the effect of the treatment cannot be accurately assessed. In a double-blind experiment, neither the experimenters nor subjects are aware of their group status. This prevents the experimenters from treating the placebo and treatment groups differently and reduces experimental bias. Randomization in experiments is common practice. Objects or individuals are randomly assigned by chance to treatment or control groups, creating homogeneous or mixed groups without involving any potential biases or judgments. There are several different variations of randomized experiment design. A completely randomized design. Subjects are assigned to groups completely at random. One standard method for assigning subjects to treatment groups is to label each subject, use a table of random numbers to select them from the labeled subjects. In a randomized block design, subjects are first divided into blocks based on shared characteristics like race, age, etc. The same way that we take individual groupings from a population to do a stratified sample. Here, we're trying to make sure that people from each of those groups are included in both the control and the treatment group. For example, age might be a significant factor or confounding variable, as they call them, in the effect of a given medication. So if you group by age, then within each age group, assign individuals to treatment groups using some completely randomized design. In a block design, both control and randomization are considered. In a study of the effectiveness of 4 different skin creams for the treatment of a certain skin disease, a researcher has 80 subjects and plans to divide them into 4 treatment groups of 20 subjects each. Using a randomized block design, the subjects are assigned, according to severity of their skin condition. The members of each of these blocks are then randomly apportioned to the 4 treatment groups. That way they don't have all the people with the worst symptoms in one group or the other. They've divided them between the 2 groups. They've divided the ones who show very few symptoms into both groups. Replication. Randomization helps to ensure that treatment groups are as similar as possible, but the results of a single experiment applied to a small number of objects or subjects should not be accepted without question. To improve the significance of an experimental result, we need replication, the repetition of an experiment on a large group of subjects. So having a large group of subjects is one of the ways in which we're replicating. The other way is to make sure that an experiment can be replicated or redone by some other researchers or at a different time. Replication reduces variability in the experimental results, increases the confidence level with which a researcher can draw conclusions about an experimental factor. And those are some of the major components of an effective experimental design.